Hello everyone. In this presentation, I will be talking about the study we did on effect of thermal and non-thermal treatments on pome fruit, a case study on Granny Smith apple, and Zanash. Apple fruits are commonly stored for long duration at low temperature under normal or controlled atmospheric conditions. During this period, the fruit gradually loses its quality, mostly related to enzymatic or oxidative and metabolic changes, as well as fungal disorders. Most importantly, apples are susceptible to high degree of fungal pathogen, including Botrytis cinerea, which is the main cause for the development of black, gray, and blue molds. And therefore, the application of various treatments, mostly chemicals, before long-term storage has been the common practice in pack houses to control these disorders. However, there is a great public concern due to the presence of chemical residue in the fruit and in the environment. So, this has motivated researchers to develop alternative pretreatment strategies, such as thermal or non-thermal treatments, which includes hot water and electrolyzed water treatment, which are uh, emerged as a safe and effective techniques. The aim to investigate the alternative approach, such as hot water and electrolyzed water treatments for decay management of Granny Smith apple. To do so, two separate sets of experiments were set up for this study. In the first experiment, the effect of a hot water treatment using 45 degrees centigrade and a varying treatment duration on the physical chemical quality and protein expression of apple fruit were investigated. And the second experiment, the curative efficacy of slightly alkalized water using different concentrations and treatment time as well against Botrytis cinerea was investigated. A few major findings from the hot water treatment experiment. In this experiment, the fruit core temperature of apple after hot water treatment was significantly lower than the surface temperature. The highest core temperature for treated apple was observed for 15 minutes, deep in duration, while the lowest was for sample dipped for 5 minutes. And the internal temperature for non-treated, which is a controlled sample, was relatively close to that of the initial holding storage temperature. And this variation in core temperature could be linked to the variation on quality. And in general, the hot water treatment duration for 15 minutes had a beneficial effect on flesh firmness, fruit color, total soluble solid, and titratable acidity by the end of the storage. From the protein expression result, we observed that the band between 15 and 10 kDa were overly expressed in hot water treated apple, whereas the band showed low intensity on fruit treated for 5 minutes and for control. But further study is needed in this case to investigate if this overexpression and low intensity could be linked to stress response during the hot water treatment. Findings from the electrolyte water treatment experiment. In this experiment, the results show that the concentration, dipping duration, and storage temperature has significant effect on the growth of Botrytis cinerea, which we try to present in these figures. Two separate experiments, which is done at 5 and 24 degrees centigrade, using 6 different concentration and 3 different treatment times. And after 2 weeks of storage, the lesion area doubled from the initial growth for a smaller concentration, which is 15 and 100 ppm. And in this condition, varying the dipping duration did not make a significant difference in the lesion area as well. And the smaller lesion area rather observed for electrolyte water, which has a concentration above 200, means the most curative efficacy was observed. And at low concentration, change in storage temperature was also observed to accelerate the growth of botrytis. And in this study, slightly alkalized electrolyte water concentration below 200 was not effective as a curative strategy against botrytis cinerea. Overall, the electrolyzed water treatment has significant curative efficacy, but based on the outcome of our study, the dipping duration beyond 10 minutes did not confer any additional benefit. So this would be probably due to the increase in botrytis resistance due to the longer period of exposure, which needs further investigation. But however, slightly alkalized electrolyzed water at 200 milligram per liter combined with a cold storage was effective in retarding the growth of Botrytis cinerea without any other physical visible quality effect on the fruit. Conclude, hot water treatment at 45 degrees centigrade for 15 minutes duration maintain the quality attributes of Granite Smith apple. Electrolyzed water treatment at 1500 ppm concentration are not effective to control the growth of botrytis, and electrolyzed water treatment using 400 and 500 ppm have adverse effects on lenticels. But however, the concentration between 200 and 300 ppm are effective to control botrytis scenario. But further studies required to investigate the impact of these treatments on the nutritional, sensorial, and functional property of Granite Smith apple and compare the results with highest temperature hot water treatment. We would like to thank ARC, Hortigrow, and ISE for supporting us to do this study. Thank you.